This is Maker Galaxy.
We're always talking about the future of design, the future of technology, the future of making. In a world where edible electronics made from fish ink could help power smart pills, a world where music ink allows users to play their own drawings, how do we find the next big thing? Maker Galaxy is a show that explores the crossroads of design, technology, and the future of making. Welcome to the show, everybody. I'm your host, Simon Martin, coming to you from NYC at EVD Media's NYC studio. And this week, our special guest comes from SolidWorks as the Director of Education, Miss Marie Planchard. Marie is responsible for the entire education leg of the popular CAD package, where she works on an international level, driving STEM education efforts from ages as early as 8 all the way through the college level. We'll talk with Marie about some of the cool projects that she's seen students doing internationally, how SolidWorks is helping drive innovation at the high school level for the FIRST International Robotics competition coming up this week, and how SolidWorks is helping drive the STEM bubble worldwide. Today's show is brought to you by CAD Junkie. For those looking to step up their CAD game and stay on top of the latest in software tips and tricks ranging from SolidWorks to Rhino and Modo to Adobe, check out more and get a free membership over at cadjunkie.com. Thank you so much for joining us on the show today, Marie. Before we go any further, I know we have a lot of SolidWorks users who listen in on the show and would love to hear more about what you do as the Director of Education at SolidWorks. So tell us, what do you do, Marie?
Well, I'm responsible as the Director of Education for the SolidWorks community for students starting around age 8 is where we start now, all the way up to college and university and also university research. So I'm responsible for looking at curriculum and content, certification and sponsorship across all grade levels.
Very interesting. And so does this also involve, working directly with educators and whatnot to come up with curriculums, or what all is involved with that, and do you develop SolidWorks tutorials? How does that all work?
Well, we start with educators to give us their direction. We go into the classroom, and we also work with industry to see what the needs of our commercial customers are. So it's important to listen to the educator, and it's also important to listen to our commercial customers. And those are the two major buckets that we direct our curriculum for. The first, as we deal with educators, is looking at STEM outreach, science, technology, engineering, and math, which is a major movement in the U.S. and also around the world, that we can provide curriculum to excite all students, no matter what their age.
Definitely.
And then, it's very important. So it could be down the street in a Massachusetts school system like Assipet Valley where we are, or it could be around the world in Singapore. Young students need to get excited and need to learn about science and engineering. And we want SolidWorks to be part of that because it is fun. It is innovative. It shows students' creativity. And we play a major role in helping educators not only use the tool, but use the tool in a classroom where it's going to make sense to talk about design principles or physics or geometry, because those are the topics that are taught.
Definitely. But what about art? Because there's STEM and then there's STEAM. I prefer STEAM because I feel like art really ties everything else together. But also as an artistic medium, depending on how you want to look at it.
I will agree that I will say that art is part of engineering. I don't think you can have engineering without art. You have to be creative. And yes, we do support the arts. When I look at the Metropolitan High School in Japan, in Tokyo, all they do is use SolidWorks in a traditional or semi-traditional art class.
Wow.
They don't call it engineering. It's only in art class, or the Mass College of Art, or Rhode Island School of Design, or the art centers. They use SolidWorks as the tool. But along with art, if I was to put art all by itself, I also would say we're in a history class. We're in ancient Egypt to look at how to design a Grecian urn and what was the weight of that on the young woman that carried it across the desert, right?
Yeah.
We can do that. We can bring in history and social studies. So I guess it's all of the humanities. It's not just art.
Definitely.
And in English class, sometimes you'll see SolidWorks there as part of an oral presentation where a student has to create a written report, and the educator is looking at language and language skills, and also it's looking at how they incorporated graphics that they've created. So it is a blending. SolidWorks is a visualization tool.
Right.
In the classroom, if you want to show something, you can use SolidWorks to express your ideas, no matter what the class.
Definitely. So, okay, back on the note of the SolidWorks use in Tokyo, what kind of stuff were they actually modeling in that art class?
They were, the Tokyo Metropolitan High School was actually modeling fruit and vegetables.
Wow.
In SolidWorks. And the work of the students were so well received that they ended up being shown off, framed in the Tokyo train station.
Wow.
So when you think about this, this change, and to me that's what's so exciting, is that gone are the days of this students waiting to their first year in engineering school, right? Their first CAD class. Gone are those days. We see SolidWorks in all sorts of classes at all different grade levels.
Right.
And that's what's. I didn't know SolidWorks could be used to design fruit, but teachers keep showing me so many creative ways that they have used and interpreted. And I'll send you the link. There's actually a case study we did on them on our website.
Excellent.
And it shows you some of the pictures that are pretty provocative, when you think these are high school students.
Oh, definitely. And I mean, on that note, you said that you started, or you do start working with students at the age of 8. What kind of stuff are they doing?
Well, most of the time at age 8 is camp, is projects that involve a good mentor, a mentor that has a very creative plan on what they want to do. And it involves things, kids like to throw or break or race something.
Okay.
And I'm going to go to one of our resellers this summer, Go Engineer, that had summer camps in 11 different cities. And they opened it up to the general public. This wasn't the students or the children of engineering parents. This was, to the general public, go to camp. And the kids actually designed this linkage, and they rapid prototyped it, and they were little.
Yeah.
And then you can see the summer camps through the colleges and universities, the engineering camps like at WPI or Georgia Tech that start with a little CO2 car, a little balsa wood car, and the students get to race these things on a track. And and paint them, and there's a little bit of art involved, and sometimes in some of the camps, if it's on a lake. There could be swimming too,
That sounds like what I want to do. I'm assuming they're also doing quite a bit of 3D printing then too.
Yes, we are seeing a lot of 3D printing. Certainly, it's been around at the college and university level for a long time.
Right.
But thanks to the government's recent push for manufacturing, there is a lot of grant money out there in putting rapid prototype machines into the high schools, and even down into some middle schools. And with that comes this mindset to the student that parts have got to be made, that parts, you can design anything you want in SolidWorks, right? Your holes could be square, you could have pockets in the middle of nowhere that can never be filled. So we want to be able to share with students the right techniques, the right way of doing things. And it's pretty easy in SolidWorks to start with a model and then go to a rapid prototype machine through STL output. But more importantly, we're also teaching students through DFM Express, through the tolerancing tools, that you also have to design this part, that it can be machined.
Definitely.
Or it could, and we want to make sure our tools are there.
You want the whole ecosystem.
Yes. I think, for me, rapid prototyping is exciting because a student can see the part right away. But then it's up to us, as someone who is trying to mentor these students through our software, that then you have to make the right decision. Should that part be rapid prototyped, or should that part be machined?
Yeah.
And if you're going to go one way or the other, what other information do you need to know? We want it so that students are hungry to learn more, right?
Definitely.
That they want to know the way to do something. They want to produce their parts. Rapid prototyping is a quick way. It's not always the solution.
No.
And we support the machinists and the machine shops as much as we possibly can with creating curriculum around components that can be manufactured or formed in sheet metal or molded in plastics.
Very interesting. And so you guys, SolidWorks, are involved with the FIRST International Robotics competition. And when I say first, that's not the first ever. That stands for something else I'll let you get into in a minute. But you are helping supply these young designers and engineers with the tools needed to build competitive robots. So could you give us a little background on the competition itself, and then how SolidWorks comes into the mix?
The organization was started by Dean Kamen, the inventor and developer of DECA with the insulin pump, I guess he's most famous for. Though I guess in the past, I think now he's most famous for U.S. FIRST Robotics, where there's so many students that start at a very young age, first Lego League. And as they go through different school levels, the robots and the competitions become more and more complex.
Okay.
So the one that we are focusing on this year, and we are working with FIRST to develop a kit of parts for our new SolidWorks electrical product.
Okay.
Is called FRC, which is First Robot Challenge. First Robot Challenge is robots in high school, that high school students, they could be part of a school. We also support organizations that do this after school, like the Girl Scouts or homeschool teams, 4-H. Anyone can start a FIRST team by applying that they're going to have a team and a robot and they have a mentor. And what we've done this year, we saw more and more customers coming to us that they were FIRST mentors. And in the past 10 years, we've always supplied software to any FIRST mentor that asked us for help. Well, this year we saw a lot more coming very early. I mean, the competition starts officially kick-off is Saturday, but starting in September, we had this big growth spurt of these teams coming to us and asking us for SolidWorks software for their robots.
So you would say in 2013 you had more requests than previous years?
Yes, almost double than previous.
Wow.
So I gave FIRST a call and talked to two people that were responsible for what's called the official kit of parts. And these are parts that are supplied to these 2,400 robots.
Wait, hold on a sec. You said there's 2,400 teams?
Yes.
Wow.
Yes, it's big. And they're across 5 different countries. U.S. is the largest, but there's also Canada and Israel, Mexico, and Australia.
That's quite a turnout.
Yeah, it's a lot of teams.
And so what's in these kits?
So the kits contain components, physical components for the most part. It's like Andy Mark is one of the suppliers. They supply the chassis rails. The students can start with the frame for their robot.
Okay.
And inside the boxes, there's different color boxes, and they're all going to arrive at these locations on Saturday. The logistics is amazing. But there's frames, and there's controllers, wheels. There are also switches and batteries. And so that's the physical kit, right? That's what gets supplied to all these people.
So it's like it's like a stock car. It's like a NASCAR car. Everybody starts with a standard, set of something to build off of, and then they come up with their own designs and whatnot to add to it.
Correct.
Okay.
And also with this physical kit of parts, with actual hardware, there is a virtual kit of parts, which is software. And FIRST has other CAD suppliers. For me, though, I didn't want to be, me too. So when we thought about our offering and what we could give these FIRST teams, we looked at our commercial customers that are into robotics.
Right.
We have a lot of commercial customers that use SolidWorks.
I'll bet.
And what would these teams need is like a robot suite of parts, not just mechanical CAD. So we put together, this is the package that these students get, these teams get. They get SolidWorks 3D mechanical CAD, which is the equivalent of premium. Okay,
so it's not the education version, it's the premium version.
No, it's the education version.
Okay.
It is an education version. It is watermarked.
Okay.
But it has the functionality of SolidWorks Premium.
Gotcha. Okay.
And it is based on 2013.
Okay.
So they get that. They get SolidWorks in this robot suite. They get SolidWorks Mechanical CAD. They also get SolidWorks Simulation Premium, which is going to give them the ability to do stress analysis and drop test. And I'm not sure how many, some of the alpha teams look at frequency and vibration, but simple stress and even stress in an assembly they can do, and thermal analysis. They also get...
Very nice.
Yeah, they get motion, kinematics, and flow simulation. And they also get sustainability, SolidWorks sustainability, to look at life cycle assessment. And then they get workgroup PDM. And what we think is really going to take off is our new product, SolidWorks Electrical. And SolidWorks Electrical allows you to create a single line or multi-line schematic. It also ties the 2D electronic layout to the 3D model.
Interesting.
And we really believe that this is going to be an eye-opener for FIRST teams. Because to be able to plan your control system and to understand in this small little footprint that you have to build your robot, where to put the wires, how the circuit is going to behave, looking at the components that are supplied by National Instruments. I mean, these are similar to components that our commercial customers are working with.
Definitely.
And it's software. Now they have the complete suite of our software tools that will allow them to design their robots.
So is this the first year where they've been offered the entire suite?
Yes. Yes.
So the robots are going to be like 1,000 times better this year.
I hope so. There's some pretty good robots. I think it's all about introducing students to the tools that are going to help them get their job done. And they only have 6 weeks to make this robot. I know a lot of teams, they kind of build as they can build with just the parts that are in hand, and then they'll sort of do their documentation later. Sounds like a real engineering situation, doesn't it?
Yes. So there's a storytelling aspect to their process and their journey as well?
Yes, there is, because after they build this robot in 6 weeks, and they put it in a crate, and it gets shipped to competition, they can't touch it. They can't touch it until they compete, okay? So that's why it keeps the playing field very fair. But then the teams have a couple of weeks before competition where they work on their documentation, and they, try to think what's going to happen when the robot actually gets on the playing field and goes and competes with other teammates. I think for me, looking at FIRST Robotics, we see more and more teams coming to us, not only for the competition, but also over the summer, where they have training sessions and camps, and they want to get better in their design. They want to have a stronger team, a stronger design team.
It's like an off-season workout for an NBA team.
I know. I heard spring training, was going to start in February. They make us feel good in Boston when there's a snowstorm, so they tell us about better things happening. But in a way, that's what FIRST is. They are teaching about engineering, and engineering is not just one project, one event,
right,
one robot. It's getting your strength up. It's always working on your skills. Do I know who's going to open SolidWorks Electrical come Saturday and play with it? No, I don't. But just telling students that something like that is out there, and that this is what engineers use when they're designing, when they're thinking about a design. It's exposure. It's letting them know that these options are available to them.
Essentially, you are enabling teams to use the entire SolidWorks ecosystem to both design their robots as well as create electrical systems in a single virtual environment. Now, let's say they have a final design. How are these teams manufacturing these robots?
For the most part, the kit of parts is their foundation, okay? And they will manufacture some key components, like a drive system, all right? They might manufacture their own drive system, or they might manufacture maybe in some cases, their own wheels.
Okay.
There are teams that have access to a machine shop, either through their mentor or through their school.
Okay.
There are some teams that do not have access to a machine shop, and they would use the standard kit of parts.
Okay.
Now, you're going to ask, how does FIRST keep this all fair? And they do a great job at that, because it's not one team versus another team. It's an alliance of 3 teams versus an alliance of 3 other teams.
Okay.
So you have to have certain levels of who is going to be on your team, and who is going to be on your alliance. And one of those team members that's on your alliance is a rookie team.
Okay.
So I saw one time a rookie team, the way the contest worked, that you got points if your robot sort of lapped the track, okay?
Okay.
And then there was points if the robot did a task, okay? Like, I don't know, it's throw a frisbee or throw a basketball or any go in and out of hoops or climb up a frame.
Okay.
Well, there was this one rookie team, and the only thing it did was go around the track. That's all it was designed for. But it scored points, right? It couldn't do anything else, but they were very smart to design their robot for the competition and what they did. And other teams, as part of the alliance, wanted that rookie to be a part of them.
Smart strategy.
Yes, it is, and it really builds upon a term that Dean Kamen trademarked, which was gracious professionalism, and that's the whole thing about this. Is that you're in competition, but you really gotta know that when you're working out there, you have to be good to people. You have to respect other people, no matter what they do or what their robot looks like.
Definitely.
You got to say, you got to say, great job, and this is what this robot is great in, and wow, you guys got here. That's amazing. To me, I'm just surprised in 6 weeks these students can put something all together and have it running and working and tested. So it's pretty amazing.
So, okay, for some of our listeners who may or may not have their own kids or family members, but want to get involved with the STEM platform or FIRST Robotics, and perhaps they're experienced with SolidWorks, what kind of ways can these users get involved with the education, or if they want to become a mentor, or what? How does that work if somebody's listening right now that wants to get involved somehow?
Well, on our website at solidworks.com/first, we show you how teams can become involved or get sponsorship. And at the very bottom, there is an area that talks about the FIRST organization. And if you click on the FIRST organization, their first piece or one of their tabs is how to become a mentor.
Okay.
I will say, in sponsorship, SolidWorks sponsors over 2,000 teams around the world. Student teams in robots, in cars. You talked about NASCAR. We love NASCAR. There's an organization called 1080 that works with NASCAR and inspiring kids with physics and math behind the physics of racing. We're heavily involved in SAE collegiate events. And if you're involved with SolidWorks and want to share that what you know, to help students at all age levels and what your interest is. I find the best mentors are the ones where they have an interest in something.
Definitely.
Right? So if you have an interest in robots, we're there for you. If you have an interest in cars, we're there for you. Solar boats, planes that fly, we do a design, build, fly sponsorship. It's kind of amazing what students will get into and be creative in. And even the industrial design sponsorship. And I know, you talked about art. I was just amazed when I went to the ADSA show and saw what industrial designers, students are doing in competition. their work with SolidWorks and outside of SolidWorks is just amazing. So if you are lending yourself more towards industrial design or automotive design or robot design, we have teams out there that can use your help.
So last question. We are seeing the entire education system being disrupted by open source learning, YouTube videos, and alternative institutions that help prospective students develop portfolios and skills without a traditional 4-year degree. With that in mind, as the Director of Education for SolidWorks, where do you see STEM and the entire education initiative moving in the next 5 years?
With the introduction of digital resources, the self-learner, and getting this new information, because whatever I say today, whatever SolidWorks is today, is going to be different tomorrow. The digital age has made learning, whatever's coming, easier, faster, and better, with far more resources than you or I ever had.
Definitely. So SolidWorks, whether it's used for engineering purposes or in an English class, is definitely a solid part of that STEM platform. So
you still have to visualize, Simon. You still have to be able to, you have ideas in your head and they have to come out somehow. And right now, SolidWorks provides the easiest platform to do that in, no matter what your age.
I would not disagree with you there. I'm a proud SolidWorks user. So with that in mind, Marie, thank you so much for being on the show today.
Oh, thank you, Simon. I appreciate your time.
This show is brought to you by CAD Junkie. Step up your 3D content creation game with hundreds of video tutorials ranging from footwear design to 3D printing. Get a free membership now over at cadjunkie.com. Thanks for listening in today, and if you'd like to find out more on Marie or the FIRST International Robotics competition, be sure to head over to solidworks.com/first. On our next episode, we'll be talking to the CEO and founder of UK-based Makey Lab, the entertainment play space for young people that invites users to download and print 3D toys and accessories. I'm your host, Simon Martin. Stay tuned and check in with us next time on Maker Galaxy.
A production of EBD Media.